with a slightly cleaned up board. I want to jump from function to form now because you might be wondering, okay, we just played around with the world of the functions. How does it protect? How does it sense? How does it do the things that we mentioned? What I decided in the last 7 or 8 minutes is that the way I want to address this epidermis, dermis, and hypodermis is I want to start out with the epidermis first. I'll start down here at that line and I'll work our way up. Then we'll work our way down. We'll look at the dermis and then the hypodermis, and I'll try and explain why it's not just simply fat. I take exception with the Encyclopedia Britannica, even though they could say, well, I'm right, because this all looks like adipose tissue to me, but there are other tissues that I think they should have included. So the epidermis, just this portion, here's what I want to do. I want to blow it up. Ooh, there we go. So there's a view. I'll clean this up a little bit more. And essentially what we have is just that little line that ran across the top, blowing up from here up to here. This is the outside of you. This is what you see. Now I mentioned in the previous video twice, 40 days. We're going to start down here at this lowest level called the stratum basale. And it's the basal level. Down here we would have a basement membrane like all epithelial cells will sit on. We talked about the different layers of that basal membrane or that basement membrane. But I want to look at this very, very narrow little layer that goes just above this. What we have is keratinocytes. And, as I mentioned before, melanocytes. And let me fix my N. Now what you're seeing the most of here are keratinocytes. These are going to be cells that their big job is to produce keratin, this waterproofing molecule. Melanocytes, we're going to have some of these down here in this basal layer, which we can think of as essentially just down here. Now the melanocytes, those are the ones that are going to be producing a lot of melanin. Now I'll probably make a few mentions about melanin, about amounts of melanin, and I'll do it from my perspective. I have very light skin. I have freckling that becomes more pronounced in the summer with more exposure to skin. It's because my melanocytes aren't evenly distributed like a lot of yours are. So is freckling weird? No, it's just what I got from my parents that say, hey, the melanocytes aren't evenly spread all the way through the very lowest layer of the epidermis. Now the melanocytes, you go, okay, well he must have very small amounts of melanocytes. Somebody who's very dark-skinned, like in Usain Bolt or Barack Obama, definitely much darker pigmented than me. It's not the fact that they have a lot more melanocytes than I do, they just produce more melanin. So that's the big difference. So I'll be coming at this from kind of my very light-skinned perspective. Now what the melanocytes are going to do is they're not going to move up through time to the top and get sloughed off like the keratinocytes. What the melanocytes do is they produce the melanin and then they hand it off to the keratinocytes. So when I'm exposed to sun, my melanocytes now really soup up the amount of melanin they produce, they pass it off to the keratinocytes, and then they head up through time towards the surface. So there's our basal layer, our stratum basale. Now if you look at this area, this is our stratum spinosum, and this diagram does kind of an okay job, but if you look morphologically, they start to flatten out a little bit. And actually, in a micrograph, they look a little bit more star-shaped, so the name came from spiny. So it's a spiny layer. So it's changed at this point. The morphology has started to change. And typically, yeah, it's about this thick, 5, 6, 7, 8 cell layers. And they start to produce pre-keratin. So down here we have these functioning cells. They're not completely keratinized. I'll give you a little hint. By the time we get up to here, they're totally keratinized and they're dead. They're filled with keratin and we're totally waterproofed at that end. Now above that, let me point out one other thing within the stratum spinosum. The stratum spinosum in this diagram doesn't quite show it. We're going to have cells that are wandering through here called Langerhans cells. These Langerhans cells are macrophages. They're the big eaters. Remember, they came from the marrow, they moved into the circulatory system, and then in the vascular portion, which is not the epidermis, but the vascular portion, they then migrated out and they're wandering through, making sure that if you have a cut, whether it's a paper cut or whether it's due to a chainsaw, it doesn't matter. What it's going to do is try and take out any bacteria. It's going to knock down infection. These are the big players when it comes to our biological protection in the skin. So spinosum, what we really see here is we're carrying towards the surface our melanin, and we're progressing through this 40-day journey, and we're becoming keratinized. So we're slowly, bad news, dying. And then take a look at the change from here to here. They've flattened out a little bit more, but now we see all of these little dots in here. This is the stratum granulosum. The reason it's called granulosum is that's a derivation of granular or granules. All of these little dots you see. This is the pre-keratin becoming keratin. And it's essentially maturing. And what that does is it means things can't move through it very well. By the time you get to the granulosum, it's choking off nutrients and oxygen and other things from moving up. So all those that are above it are slowly beginning to die. So these superficial layers are literally getting suffocated. Now there's a lucidum, a stratum lucidum. This you only find in certain portions of the body. And it's what we call thick skin. If we had been doing some more lab and I'd have you dive into the scopes, you'd look at thick skin and thin skin. My forearm, your forearm, it's all thin skin. It wouldn't have a lucidum in it. But the thicker portions, the calloused portions of your hand, the balls of your feet, the heels of your feet, the areas that take a lot of extra physical pounding, they have a lucidum. So it's just an extra layer for physical protection. By this time, your keratin production is complete. You've now completely keratinized. Then we get to the stratum corneum. And this is what you're looking at when you see the outside of your skin. This stuff is completely dead. It's completely keratinized. Not a whole lot wants to move through this physically. We mentioned absorption with things like drugs. And acetone, that can move through, but most things can't. You can't jump into a pool of water and have the water rush into you because you're literally physically protected from the outside going in. That's the epidermis. This is what I think we're most familiar with. Think about this for a minute. I'm not going to give you the answer. Just something to roll around in your head. What would happen, a number of you have tattoos that I've noticed. What would happen if when you did a tattoo, you injected the ink here? you'd be inking yourself, but what would happen? Think about how long your tattoo may last. Also down here, one of the things that I wanted to mention in my rush that I jumped over, this basal layer, it's stem cells. These just continue to divide and divide and divide and divide and divide and divide via mitosis. So when we talk about stem cells in the news, or we talk about, oh, stem cell technology, it's not a really foreign thing. We've all got stem cells, and this is just one of many examples of where you would find them, or many locations of where you would find them. So that essentially is the epidermis. Now if I go back, wrong way, there we go. We can now look at the dermis. Let's move down a little bit. Let me clean this up. What we just did, what we just looked at, was from here to here, or from here to here. So you go, wait, some parts are really thick, some parts are really thin. That's true. This dermis, wait a minute, I just did, yeah, that's what I was meaning to do. This dermis that may seem on the far left-hand side really thick, or as we move over relatively thin, is actually made up of 2 layers. And I want to explain why some of it looks thick and why some of it looks thin as well. At the top, the most superficial of the dermis, it's called the papillary layer. And that makes up about the top 20%. It's relative, it might be a little bit more, it might be a little bit less. The lower level, and that's not shown on this, you can't see it in this image, is what's called the reticular layer, which makes up the remaining roughly 80% of the dermis. Now what's the difference? The papillary layer is primarily areolar tissue. Remember that hodgepodge connective tissue that had all 3 fibers? That's what we tend to find more superficial. Also, we've got some nerve endings. I want to address the nerve endings when we get to the extras that I've got written up here that you can't see. Nerve endings, glands, these very distinct hairs that are sticking out here. I'll address all of that in the next short video. So we've got the papillary at the top, and what's very distinct is the papillary layer, which is up here, terminates, and whoa, that one goes way down. It terminates in all of these bumps and lobes. What these bumps or lobes are called are dermal papillae. Papillae are little extensions like this. You're going to find them when you get around to the digestive system. You'll find them when you look at the structure of the tongue when we talk about special senses. But there's a really simple reason that you're going to have this in this formation instead of a straight line across. And it's so your epidermis doesn't slide off your dermis. You know, if you put a lot of pressure pulling skin in one direction, it would have shear force and it would be able to pull off and you would separate those two, which is not good, especially because you have a lot of pain receptors in there and you don't want to start to pull those two apart. Reticular, we have dense connective tissue in the reticular. And I think a couple of things that could be interesting about reticular layers is that we tend to have our collagen fibers going pretty much in one direction, in one plane. which is why surgeons are going to decide if they're going to do an appendectomy or something like that. And all they have to do is get through the skin and then muck around with the soft tissue below. They want to make sure that they do the incision along with the plane of the fibers. If you go against it, it makes it a lot tougher to be able to heal without big scarring. If you go with, you can minimize the amount of scarring. Also, stretch marks. If you've ever seen anyone who has lost a lot of weight, could be because they were severely overweight and then they lost a lot, or in many cases as well, pregnancy. All of a sudden there's a distension of the abdomen, and afterwards you have these little lines of stretch marks. That's where some of these collagen fibers have been torn in the reticular layer. I'm trying to dance around a lot of these nerve endings for a few minutes, or at least until the next video. There are a number of them in here that I want to talk about with this layer, but I'm going to hold off on that. The hypodermis, down here at the very bottom, the deepest of the epidermis, not of the epidermis, sorry, of the integument. It's areolar and it's adipose. And it's what we find between, say, for example, tendons and bone and the skin itself. And so it's kind of a transition zone. So we tend to have, at least speaking for myself, I have a lot more hypodermis than I do dermis and epidermis combined. So we've got these three layers kind of hammered out. We've named them, we've defined where you find them, but we've got all of these extra things in here, from erector pili muscles and oil glands and sweat glands. That's what I want to talk about as I keep checking my time in the last integument video that I want to do today. So this is where I don't like saying any questions, because you're not going to answer. You can email me in my office. Let me kill this, switch it around a little bit, and we'll get right back at it.